Okay, so we want to show that the volume for a cylinder is pi r squared h. I'm going to draw the cylinder for you guys. Here's your cylinder, and it has a height h. It has a radius, big R, right? And it goes from its angle, right? It's a full cylinder, so it goes from 0 to 2 pi. Okay, now, quite obviously, since it's a cylinder, we want to use cylindrical coordinates. Does anybody remember the cylindrical coordinate Jacobian? Okay, well, I'll just write it out. So it's r dr d theta. You want to use this. This is equal to dA. Use this if integrating any cylindrical surface. Okay. So r dr d theta. Okay, what are we going to do? Well, we know that the volume of any surface is equal to this dV. And we know that over some region E. My God, my integral signs are terrible today. Can't be drawing these guys like that. E, let's write it like this. We could write dA. And we'll call this dz. Right, so that's a way you could think of dV here in this case. For us, we're going to think about it a little differently. I just wanted to show that, right, every single surface, like all 3D surfaces, well, in this case, this surface especially, right, the area is a circle, and then you integrate up, right? So that's why I wrote it like this. So we're going to integrate the circle, and then we're going to integrate up. Okay. So for us, let's start with this guy. And I'm just going to write region, I'm going to call it area. Right? So we're going to integrate a circle. So that is from 0 to 2 pi. And what? 0 to big R. And then we use our spherical Jacobian. Not spherical, our cylindrical. I hope I haven't been saying spherical the whole time. We're using our cylindrical differentials. Right? And what do we see this to become? The R. Okay, so this integral, r dr, from r to 0, it's going to be r squared over 2. Then d theta, 2 pi, that's just 2 pi, which is equal to pi r squared. Okay, that's pi r squared, so that's this part. And then dz. What is dz here? Our height. And it goes from 0 to h. Thus, it's just h. Okay, now as you can see, our volume here, our volume is equal to this guy times this guy, which is pi r squared times this. Okay, look at that. See, we proved it. All we had to do is we had to identify what type of system to use, which is a cylindrical system, or cylindrical coordinate system here. And then we had to identify what we want to start with. We want to start with the base, which is the area. So we're just going to do a simple double integral. And then after that, we want to identify that we still need to integrate the volume. So we have to do one more parameter, which is the height. And we call that dz, the change in height. And it changes from 0 to h, which is h. Therefore, the volume is equal to pi r squared times h.